Yeah, welcome to the session. Now, up to now, we have discussed about capital markets, capital market instruments, the theories behind the markets. We started with the risk-return characteristics of assets and different theories governing the risk-return characteristics of markets and assets. And we have gone through the basic principles of portfolio theory. And there we just discussed about efficient frontiers, where we talk on assets as well as portfolios and their respective weighted average returns and the overall risk. We measured the risk in terms of standard deviation or volatility. With that, we have been able to structure a model where we can plot the risk-return characteristics of different assets and portfolios into a graph. And if we do it for a two-asset portfolio, and after changing the weights of each asset in the portfolio, then we got risk-return characteristics of all these portfolios. And we have just realized that with different combinations of weights, we can have infinite number of portfolios with two assets. Now, when you go into 2, 3, 4, 5, or 6, or more than 6 assets, we have just realized that the total portfolio's risk and return will depend on the each asset's weight in the portfolio. So we have already understood that we can have infinite number of combinations of that, an infinite number of points we can plot on the graph, where we got the horizontal axis as the risk or the standard deviation and the vertical axis as the return. Now, if you do that, you get a plot, and we have already now understood we can demarcate a boundary which we call the efficient frontier. And when you have the efficient frontier, we then realized if we add risk-free asset into those portfolios and have a combination of different weights, you will end up with a set of portfolios where the efficient frontier becomes a straight line. That straight line is a tangent to the earlier efficient frontier we have got. So now, after adding the risk-free asset, you got a straight line. That straight line is a tangent to the earlier efficient frontier. So such straight lines, or that straight line, is called capital market line. And we went through the capital market line and we followed different aspects of capital market line. And there's a particular point where the capital market line touches the efficient frontier, and that point represents the market portfolio. From that point, the capital market line divides into two parts. The part which is left to that is called the lending portfolios. The part which is left to the right to that point is called the leverage portfolios. And we went through several combinations of risky assets and risk-free assets, where you found in leverage portfolios, you had a borrowing, and you borrowed assets and invested those assets in a risky form. Now, such portfolios are called leverage portfolios. And we followed a very specific methodology to apply those things, where the weights are being given as minus. The minus represents the borrowing. Now, it's a very interesting point to note, where we deal with investments in positive form and borrowings in negative form. In other words, borrowing can be defined as a negative investment. Negative investment. So likewise, you will see the different aspects we have followed when we went through those things. And we had a fair knowledge on these things now. At the same time, we went through the stock market operations also. In that case, we just followed the Colombo Stock Exchange daily and the Colombo Stock Exchange monthly reports. And we got several information through those documents. And when you find that the different information, we can derive from those information several factors relating to the stock market. And one such important factor is the beta factor of different stocks. Now, beta factor is explained as the particular stock's return relative to the market variance. The correlation of certain stocks return with the market and how it is being described in relation to the market variance. So that is how the beta is classified, or beta is defined. Then we went to another theoretical operation where we call it capital asset pricing model. The capital asset pricing model is a mathematical relationship between two variables. Now, one is the beta of the particular stock or whatever, and the other one is the return. That return is known as the equilibrium return. So when you have that two variables, beta is taken as the independent variable, and it represents through the horizontal axis, and the other one is the return, equilibrium return, that is represented through the vertical axis. When we do that, you get a straight line. That straight line is known as the security market line. Security market line. So there, the security market line is a relationship between the beta and its equilibrium return when you talk in terms of stocks. And beta is a determinant, or it's an indicator of certain things, and it really signifies the systematic risk of a stock, which we cannot contain through diversification. So this beta is a very critical factor in the capital asset pricing model, and capital asset pricing model is described as the equilibrium return is equal to the risk-free return plus the risk premium into beta. So that's a very important relationship. And we know that government securities, the fixed income securities, and stocks, they generate returns. They generate returns. Now today, we are going to discuss about the returns generated by stocks. And through that, how we can find out the value of the stock or value of the different stock. The value of the stock depends on the future cash flows it would generate in the life of that asset or the stock. So then you have to just consider what are the types of cash flows you would receive with regard to a stock. Now you all know most of the companies, they declare dividends. Sometimes they declare dividends in several times, in several forms. Right. Now, when we go into those things, the dividends can be declared in several formats. Now, I think you heard about interim dividends, final dividends, and that type of things. Now, I will just show you now the types of dividend declarations for certain companies. But in our study or our valuation process, we have to just assume the dividends being declared and the rate of dividends or whatever during a year. So now when we do that, we will see how these things are calculated and how we can determine the real value of a stock by going through the dividend cash flows and other cash flows which we expect. Now, when we talk about the other cash flows, it can be sales proceeds of a stock. So therefore, we just want to see how we can apply the principles into that cash flows. Now I will go to the lesson now. Now I just have seen a certain query where someone has mentioned that the portfolio theory has to be applied to the treasury portfolios also. But I think that is also, now when you apply portfolio theory to the treasury portfolio, the treasury, in treasury assets or whatever, treasury bills or treasury bonds can be taken as risk-free assets. But when you say treasury portfolios, I don't know what does that mean, because treasury portfolios are portfolios normally maintained by treasuries, if that is the case. So there you might have risky assets and risk-free assets, both. So then when we deal with those things, same portfolio theory applies there. Not only the risky assets. I mean, you might have risk-free assets also there. So therefore, there may not be any difference when you talk in terms of treasury portfolios, when you talk about the portfolio theory. Right. Anyway, now I will go to the lesson now. Now today our lesson is common stock valuation or equity valuation process. Main concepts covered under this lesson unit are as follows. Now first thing, we just go through the discounted cash flow approach. Then the required rate of return, risk-adjusted cost of capital of a stock. Then constant annual growth of dividends. Then one-stage model on stock valuation. Stocks with substantial annual growth of dividends. Two-stage cash dividend model on stock valuation and valuation of stocks under earnings approach. Now these are the topics we expect to discuss during this lesson. Now when we discuss about this discounted cash flow approach, this is the normal present value of money theory, type of a theory. And we assume the dividends declared or dividends received on account of a certain stock in a particular year is certain amount. And the other assumption is we receive that particular dividend at the end of the year. Now all those assumptions are in this discounted cash flow approach. Now when you get a particular stock, if its present price is B0, we can have a statement or we can have a relationship giving or evaluating the present price of the stock by this relationship. Now there what we did was we have taken the dividend cash flows for each year as for years 1, 2, 3 and so on. At the first year the dividend cash flow is D1. At the second year the dividend cash flow is D2. At the end of the third year the dividend cash flow is D3. Likewise we have taken the dividend cash flows. And we have taken it as an infinite number of years. So since the stock is taken as a perpetual stock, so the last dividend is taken as the D infinity. So that is the infinite, the last or infinity year, the year of infinity. So the dividend has taken as D infinity. Now, how do we get these dividends into the present value? Now, at the end of the first year, you receive a dividend of D1. So that is being present valued by dividing it with 1 plus K to the power 1. At the end of the second year, the dividend cash flow is D2. And the present value of that has been taken as D2 divided by 1 plus K to the power 2. Now you can just look at the way it goes. Now if you have D3, then D3 plus, plus D3, now the third term would be that, D3 divided by 1 plus K to the power 3. So likewise it goes on. And the the last one, if you say the nth year, it would be dn divided by 1 plus k to the power n. Now, in this case, P naught is the stock's expected price or value. D1, D2 up to D0 denote the expected dividends per share for the year 1, 2, and infinity. K is the stock's required rate of return. Now, when you talk in terms of K is the return on the stock. Or the sometimes we call it required rate of return. Required rate of return. You remember that we did a certain calculation on capital asset pricing model. There you just calculated the equilibrium return on stocks. That equilibrium return is also being taken as the required rate of return of a stock. So therefore, now you can see the connection with this stock valuation using the dividend cash flows and the relationship with this one, relationship of this one with the capital asset pricing model. Because the capital asset pricing model is giving the value for equilibrium return of a stock. And here in the stock valuation equation, the required rate of return is a factor. So with that required rate of return, this can be connected to the capital asset pricing model. So we will see how these things can be connected to this capital asset pricing model and how we can solve different types of problems by using this methodology. And this required rate of return sometimes referred to as risk-adjusted rate on capital, return on capital. It's a company-specific value most of the cases. For each company, the required rate of return is a specific value. Now you can see in our other discussions also, we have to get several assumptions. We have to consider several assumptions. In this case also, we having a set of assumptions. Now, in this basic, among these basic assumptions, this constant annual growth is a very important one. So there we assume the dividends grow at a constant rate. That is our main assumption in this stock valuation process. The dividends grow in a constant annual rate. I can give an example. Say, in the present year, the dividend is, say, 10 rupees per share. Second year, it is, say, 12. So what is the rate of growth? This year's dividend is 10. Next year's dividend is 12. If that is the case, what is the rate of growth? 12 minus 10 is 2. 2 divided by 10 is 0.2. That is 20%. So if that is the case, now in my example, I have given dividend as 10 for the first year and 12 as for the second year. Then the dividend growth is 2. The dividend growth of 2 became materialistic or became material from the dividend of 10 at the first year. So then it's a 20% growth. Now, in the next year, so in the third year, now we talk about year number 0 and year number 1. In the second year, in that case, if the same growth applies, then it would be 12 into 0.2 plus 12. 12 into 0.2 plus 12. So likewise it goes. Now it is been explained here. Now in this case, the dividend growth is denoted by simple G. Now year 1 dividend or D1 is equal to D0 into 1 plus G. So that is how the growth is added. D0 into 1 plus G. So in other words, if you want to get the first year's dividend from the present year's dividend is 10. In our example, our growth rate is 20. So therefore, the second year's or the first year's dividend would be, present year is 0, first year is 1. The first year's dividend would be 10 into 1 plus 0.2. So in other words, it is 10 into 1.2. 10 into 1.2 is 12. Now you can just see how we can go to the second year's dividends. Now you can just see the second year's dividend as D2. D2 is taken as D1 into 1 plus G. D1 into 1 plus G. So therefore, now if you want to get D2 in D0 terms, you can replace D1 with the first relationship. That is D1 is equal to D0 1 plus G. So in the third line, you can see, in the second line, you can see D2 is equal to, now just for the place of D1, we have replaced D1 with D0 1 plus G. And 1 plus G is already there. So then you get D2 as D0 into 1 plus G to the power 2. In the same manner, you can show D3 is equal to D0 1 plus G to the power 3. Yeah. So then this can be taken as a certain pattern. If you go to Dn, Dn is the nth year dividend. It is equal to D0 into 1 plus G to the power n. Right. Now, I just want to show you these things on the board, and I think that would really give you a clear understanding of that. Up to now, I have mentioned about the assumptions. The assumptions are these. In the companies, whatever the way they declare dividends, our assumption is that dividends being paid at the end of the year. And they just have final dividends. But if it is otherwise being done, say half-yearly dividends being paid, if that is the case, that also can be taken into consideration. There's no issue. But in normal circumstances, we assume the dividends being paid at the year end. That is the assumption. And at the same time, there's another assumption. That assumption is every year the dividends grow by a certain rate. And that rate is a constant rate for each year. So that is the other assumption. Then we have another assumption, the specific assumption for each company or each entity, their required rate of return or weighted average cost of capital or something, but normally we call it the required rate of return or risk-adjusted return on capital. There's another terminology where we can say It is the same as risk-adjusted return on capital or required rate of return. So these assumptions are there in our stock valuation process. Then we go to the one-stage model for stock valuation. There the assumption is mentioned. If we assume that the dividends will grow at a constant rate forever and that the stock's required rate of return will be greater than the dividend growth rate, then we can establish the following equation determining the value of D0. So I will just show you the way it can be done on the board. Now these are the assumptions. Assume the stock price as B0, present dividend as D0, constant dividend growth rate as G, required rate of return as K. Now if you have these assumptions and the present dividend is D0, then the first year's dividend would be D1. Then D1 can be given as D0 1 plus D. Then if you want to put the D2, D2 is D1 into 1 plus D. D1 into 1 plus D. Now, here we have, in addition to the D0, there's no D0 here, but we need to get all these things in D0 and Ds. So therefore, we can just replace D1. Now, D1, we have another relationship where D1 is equal to D0 1 plus G. So what we can do is, we can replace D1. So when you replace D1, what will happen is, D0 1 plus D comes here, again into 1 plus D. So then it is equal to D0 1 plus D to the power 2. D2 is equal to D0 1 plus D to the power 2. Now, if you go for D3 also you will see D3 is equal to D2 into 1 plus D. Now we can replace D2 with this. Then D3 is equal to in the place of D2 we can apply this. Substitute D0 1 plus D to the power 2 into 1 plus D. Then it comes to D0 1 plus D to the power 3. Now looking at this, you can just observe a pattern. D1 is equal to D0 1 plus D. D2 is equal to D0 1 plus D square. D3 is equal to D0 1 plus D to the power 3. Now you see the pattern. With that pattern, we can establish this. Dn is equal to D0 1 plus D to the power n. To the power n. Dn is equal to D0 1 plus D to the power n. Now this is the pattern we have established with these assumptions. Now we will see how we can arrive at the stock price by having, now we have already assumed the dividends, cash flows as D1, D2, D3 and so on. And with those dividend cash flows, considering that the stock is a perpetual one, we arrive at the price of the stock. Now, what is the price of the stock? If you look at it, it is the present value of the future cash flows, the total of the present value of the future cash flows. That is equal to the present value or the present price of the stock. The present price of the stock we have denoted it as B0. Therefore, we can just show this way. B0 is equal to D1 divided by 1 plus K. Now, this is, when you say D1, D1 is what? D1 is the dividend paid at the end of the year 1. D1 is that. So, what is the present value of that dividend? D1 divided by 1 plus K. K is the required rate of return, or that is the discounted rate. Now, when you say next cash flow would be, the next cash flow's present value would be D2 divided by 1 plus K to the power 2. Third one would be D3, 1 plus K to the power 3. So you go this way, and the last one we assume as Dn, 1 plus K to the power n. But there's no n to this n. If you say it is 100,000, someone else can say it is 101,000. So likewise, there's no n to this, and it ends in infinity. It ends in infinity. So therefore, you can just give this relationship as the value of the stock or the price of the stock, present price of the stock, and it is denoted as P0. It is denoted as P0. Yes, I think this Asank has asked different questions. Anyway, I will come to that later. But he has asked something, why it is taken only the growth? Why not declining situation? Yes, we will take declining situations also. That is also a possibility. So if a declining situation is there, the G is become minus. That is how it happens. And can required rate of return be changed? Yeah, there can be changes. I think Asanka, I think you have a very good thinking. So that is why you have asked this type of questions. Anyway, it's a good thing, I think. That is rather than just silently listening to things. If you raise questions, that's a good thing for the others also. There can be changes, but we assume that there's no change as such. I think your point is very valid, because the required rate of return can change. But in year by year, it can be changed. But in our calculations or our evaluations, we have several lessons. That's what I told earlier. I have started the lesson with those assumptions now. So those assumptions are really, we have just had that assumptions in order to have a simple explanation. That is the first principle. But we can see if these assumptions are not valid or not true, then what are we going to do? So that is the next thing we are going to do. As you say, as Asanka says, the required rate of return can change. But in our calculations, the formulas and all, our main assumption is required rate of return is constant for the period we are referring to. So that is how we do it. And in D2, it can be changed. That is correct. But in our calculations, we assume that it is same. There's no change for the required rate of return for the total period. That is our assumption. Because now in every theoretical forms, there are a set of assumptions. Now those set of assumptions we have to think about. But that doesn't mean that we just do those things only with those assumptions. But we will now, I can just show you, when these assumptions are not true, what could be the situation? So that type of things also we study. But as per your syllabus, I don't think that is necessary for you, because if that is the case, the K will become variable, another variable. And so when the variables are becoming higher and higher, then our given solutions would be very much difficult, and you have to use complex mathematical formulas for that. So that is the issue. But anyway, I really appreciate his ideas, because he just realized the real situation. That is why he has asked that type of questions. Anyway, for the others also, I am telling that now we do all these things with several types of assumptions. And those assumptions may not be true all the time. There can be changes. But in that case, then we have to see how we can solve the question or solve the problem. So then we have to use several other methodologies to do it. Now we can use several analytical forms to do that, but it is not under your purview. That is the issue. So therefore, under your purview, we have these assumptions, and we think that these assumptions are we can really think it as true. If the assumptions are not true, then the results also will not be valid. I think Asanka has now a good idea about these things. Anything else you need to clarify on this? Decline situation also there now, as you said. Okay. Right, now we have been discussing with regard to the calculation of the stock value. And I really appreciate, and I just invite all others to raise this type of queries, and that will really enhance the quality of this session. And you also will be better, you can have your knowledge in a better manner, and you are live also. You will become live also. And I think that's a good way of learning. Right. Now I just put the relationship. P0 equals D1 divided by 1 plus K. That is the present value of the year 1 dividends. D2 divided by 1 plus K to the power 2. That is the present value of the year 2 dividends. Plus D3 divided by 1 plus K to the power 3. That is the present value of the year 3 dividends. And I have put dots because it is not possible to write everything, but you have to assume that. And the last one is Dn, nth year, Dn divided by 1 plus K to the power n. Now we will see how we can solve this, because now there are several unknowns here. Now with several unknowns, it is very difficult for us to arrive at an answer. So therefore, what we do is we just simplify those things. And I have shown you how you can replace D1, D2, D3 and Dn with D0 and G forms. Now, in the place of D1, you can put D0 into 1 plus G. In the place of D2, you can put D0 into 1 plus G to the power 2. In the place of D3, you can show D0 into 1 plus G to the power 3. Likewise, you can just go into Dn also. Then Dn can be replaced as D0 into 1 plus G to the power n. I will do that in the second line. Is it okay to write here? So what I do here is, now P0 is equal to, now in the place of D1 I can put D0 1 plus G divided by 1 plus K. Second one would be D0 into 1 plus G to the power 2 divided by 1 plus K to the power 2 plus D0 1 plus G to the power 3 divided by 1 plus K to the power 3. Now this goes to n. I will. No, since it is not very clear if you write here, so therefore I can just put it here. Plus dot dot dot, then D0 into 1 plus G to the power n divided by 1 plus K to the power n. Yes. Now, just to see, now you can see the left side of the board, right side of the board, there you see P0. I have just replaced D1, D2, D3, Dn with D0 terms. Now you look at that relationship. P0 is equal to D0 into 1 plus D divided by 1 plus K. I have just replaced D1. Then next second one, D2 also replaced D0 into 1 plus G to the power 2 divided by 1 plus K to the power 2. D3 also I replaced D0 into 1 plus G to the power 3 divided by 1 plus K to the power 3. So all being replaced, and the last term I have taken as D0 1 plus D to the power n divided by 1 plus K to the power n. So that is how it is being replaced. Now you can see, I think you have heard about geometric series. Have you? Geometric series. Have you heard about geometric series? I think most of you have done mathematics in year 10 or year 11. There you had if you had studied those things in single medium, these were known as Gunottara Shreni, geometric series. Now in a geometric series, there's a common ratio. There's a common ratio. Now if you take this as a geometric series. Now the right hand side of this equation, right? Can you tell me what is the common ratio of that? Common ratio. Now I will just give you an example of a geometric series. Right. I will put a geometric series on the board. Right. Right. I have given here 5 terms of a geometric series: 3, 9, 27, 81, 243. What is the common ratio of this geometric series? 3, 9, 27, 81, 243. Now I am just giving you a small thing. Yeah, you can apply these things. So just tell me the common ratio of this geometric series. What is the common ratio of this? You can see the things clearly here. I will tell it. 3, 9, 27, 81, 243. There are 5 terms in the geometric series. The first term is 3, second term is 9, third term is 27, fourth term is 81, fifth term is 243. Yeah, very good. It is 3. The common ratio is 3. Very good. Common ratio is 3. Others also should understand that. Now, what do you mean by common ratio? What you can do is you need to divide the second term by first term, third term by second term, fourth term by third term. Likewise, you have to do. Now, if you do that and you find the common value for that, then it is become the common ratio and it will become a geometric series. Now, say for example, here you can see if you divide 9 by 3, you get 3. If you divide 27 by 9, you get 3. If you divide 81 by 27, you get 3. If you divide 243 by 81, you get 3. So that is the common ratio. That is the common ratio. Right. Likewise, if you can tell me, now do you think that this is a geometric series? Is this a geometric series? I'm just asking you. Is that a geometric series? Yes or no? You can give that answer. Is that a geometric series? You can give an answer. Yes, very good. It is a geometric series. And if that is the case, what is the common ratio? What is the common ratio? Yes, good. 1 plus g divided by 1 plus k. Very good. That is the common ratio. That is the common ratio. Yes. Others can also understand, no? It is 1 plus g divided by 1 plus k. That is the common ratio. Okay. Now I will show you how you deal with that. Right? Is it okay to erase these things? Right. Then again, you have now for each of these terms, you have D0. What you can do is, you can take out D0 because D0 is common for all. D0 is common for all, so that you can take D0 out. Then you have 1 plus G over 1 plus K, 1 plus G to the power 2 over 1 plus K to the power 2, 1 plus G to the power 3 over 1 plus K to the power 3, 1 plus k to the power n divided by 1 plus d to the power n. Now you get this type of a thing. Now what we can do is, we know that the now within the bracket you find a geometric series with a common ratio of 1 plus g divided by 1 plus k. A geometric series. That I think you all agree. As Ruchira also said that. Anyway, I want to just get others' opinion also. Are you okay with this explanation? Are you okay with this explanation? Yes. I didn't get anything from you, but anyway, I feel that you are okay with this explanation. And what I did was I just took D0 out from the thing, and then I open brackets and put the other things into the bracket. So now you can see within brackets a geometric series. Within brackets you see a geometric series. In that geometric series, what is the common ratio? As Sanka said, it is 1 plus g divided by 1 plus k. That is the common ratio. And it is not only the common ratio, it is the first term also. First term is 1 plus g divided by 1 plus k. That is the first term. Right. Now I just want to show you. I don't know whether you remember the summation of a geometric series. That there's a formula for the summation of a geometric series. There's a formula. Now we have to apply that formula now. We have to apply that formula. Summation of a geometric series. Right, anyway. I really don't need to just give you a certain confusion into your mind. But I can just put that formula, and I can use that formula and arrive at the formula here. But I just think that if you can remind those things, your early school days, I mean, when you are in grade 10 or 11, you must have just gone through these things. You have any idea about that? The summation of a geometric series? Gunotra Shreni Kaikya. Summation of a geometric series. There's a formula. There's a formula. So we can now make use of that formula. Without going into that, the formula, I will just come up with the summation of this geometric series. And there's another explanation here, because now in this model, we assume that G is less than K, or in other terms, K is greater than G. This is the assumption. Because if it is not the case, there will be another problem. So therefore, we have to assume that K is greater than G. Now, I think when you look at it, it looks little funny. because there are several assumptions, and it goes out from the reality. So it goes pretty out from the reality. So that's a very, awkward situation. But I think the life is that normally. So in order to have a certain type of estimation, we do this. But in most of the cases, dividend growth rate is very much lower than the required rate of return. That is the normal case. If you take, say, 100 companies, about 97 companies have a growth rate which is less than the required rate of return. So therefore, it is the normal way. And that assumption do not have a unfairness or biasness there. So therefore, that assumption is not a irrational assumption. It's a rational type of an assumption. And with that, we can devise the common ratio is less than 1. Less than 1. So that is our condition. Since G is less than K, 1 plus G or 1 plus K is less than 1. With that, we can arrive at a solution. Now, if you have a geometric series with a common ratio less than 1, you can give its the summation of infinite number of terms equal to a certain value. There's a formula for that. I will repeat the term. For a geometric series where the common ratio is less than 1, we can arrive at a formula for the summation of its terms, summation of its infinite number of terms. So we call such series an infinite series. Now here also you get an infinite series because the particular stock is a perpetual one. There's no limitation for the lifetime. Therefore, we can really use this formula. So you can get the total of or summation of a geometric series where the common ratio is less than 1. For such a series, I will give you the total or some summation of a series in a formula. That formula gives you the summation is equal to A divided by 1 minus R. A is the first term of the series. R is the common ratio of the series. Is it okay? Right. Now I will repeat what I have said. Now in the process of getting the value for the stock, we devised a certain relationship. V0 is equal to a particular sum of items. We have seen that the items are in a geometric series with a common ratio of 1 plus G divided by 1 plus K. And another situation we have considered, that is the growth rate of dividends is less than the required rate of return. So with that condition, now we have realized 1 plus d divided by 1 plus k is less than 1. Less than 1. If it is less than 1, the summation of an infinite number of these geometric series, infinite number of terms in that geometric series, will have a formula to give that summation. That formula is equal to A divided by 1 minus R. Right? So then I will just repeat that formula. The total of the geometric series, the terms of the geometric series is equal to A divided by 1 minus R, where A is the first term of the geometric series, R is the common ratio of the geometric series. Right? Right. Now I have just shown that relationship, and then I will put the formula, the summation formula. Since assuming G is less than K, it is clear that 1 plus G or 1 plus K is less than 1. So the common ratio of the geometric series is less than 1. Therefore, the summation of the series is given by A divided by 1 minus R, where A is the first term, R is the common ratio. Right. Okay. Now, just look at this. Now, we assume the growth rate of dividends is lower than K. K is the required rate of return. Now, since this is assumed, we can see that 1 plus G or 1 plus K is less than 1. Because 1 plus D is less than 1 plus K. So therefore, this is a quotient. Right. So the common ratio of the geometric series is less than 1. So this is the common ratio. It is less than 1. It is less than 1. Since it is less than 1, the summation of the series is given by this formula. What is that formula? A divided by 1 minus R. What is A? A is the first term of this geometric series. R is the common ratio of this geometric series. Right. I am now asking you a question. Now, if you have followed it, you should be in a position to answer my question. Now what I am asking is, what is the first term of this geometric series And what is the common ratio? I think Asank has already given the answer. But I want to just get the first term of this geometric series also. What is the first term of this geometric series? I have just given this geometric series there within the brackets. Yes, Pradipika, first term is not D0. D0, actually D0 I have taken out. That is a common factor, D0. But I am referring to the series which is given in the brackets. Ruchira's answer, you have come to the come very close, but it's not the answer. I am asking the first term. First term. Now you understood the common ratio is 1 plus GO 1 plus K. That is the common ratio. Now I am asking the first term. Ruchira, I think you can. No, not D0 into 1 plus D. D0 is taken out, right? D0 is taken out. Within the record, you get other things. 1 plus D divided by 1 plus K plus 1 plus D to the power 2 divided by 1 plus K to the power 2. Likewise, it goes, right? So therefore, what is the first term there? The brackets, in the brackets. Oh, very good. 1 plus G or 1 plus K is the first term. Asanka, correct. 1 plus G or 1 plus K, that is the first term of the series. Now, D0 we have taken out, right? It is the common factor. We have taken it out. Now, we have come to a situation where we try to see the summation of a geometric series with the first term 1 plus GO 1 plus K, and the common ratio is also 1 plus GO 1 plus K. Right? Now we will, now I just have given the formula. So what is the formula? A divided by 1 minus R. A divided by 1 minus R. Now can you see what is the summation? Can you see what is the summation? Asanga, try it and see what is the summation with the formula. Now this is the formula. This is the formula. A divided by 1 minus R. Now you have to apply the terms into the formula. A is the first term. R is the common ratio. So what you need to do is, you need to substitute the values there. And make sure that ultimately we try to arrive at the value of P0. No? Then you have to do that. Now P0 is equal to D0 into the series. Then we get the series value and then we have to multiply it with D0. So then only you get the answer. Right. Can you do that? Now I have already given you the formula. Ruchira, you can try. Pradipika, you can try. You got the formula, no? This is the formula. A divided by 1 minus R. A is the first term. R is the common ratio. Yes. Anyway, I will do it for you. But I just I would like to have you to enable you to do it. I can just give you a chance to do it, and you also feel very confident if you do that. Right. Anyway, now we will have to find the value of this. This is the summation. Right. Then I can see D0 is equal to D0 into A. A is 1 plus G divided by 1 plus K. Then 1 minus R. 1 minus 1 plus G divided by 1 plus K. Right. Now this is the form. This is the form. D0 into 1 plus, now this is A. 1 plus G over 1 plus K. Then to the denominator you get 1 minus R. R is also 1 plus G, 1 plus K. Now how are we going to solve this? Now in the denominator what you can do is, you have 1 plus K here. Now I will do it here. D0 to D0 into 1 plus G, 1 plus K. This is the denominator, so we can say 1 plus K comes here. Then minus 1 minus G divided by 1 plus K. This is the next step. Now since this is the denominator, now you can see 1 plus K minus 1 minus G. And 1 and minus 1 cancelled off. And you retain K minus G here and 1 plus K as the denominator. Now you have two quotients in the numerator and denominator. Now what happens to the denominator? It will just get the reciprocal of that, so we will get this way. I will put it here. D0 is equal to D0 1 plus G divided by 1 plus K. Then this 1 plus K goes to the other side. Then 1 plus K comes here. Then in the denominator you get K minus G. And this will be cancelled off. And you get D0 is equal to D0 1 plus G K minus G. Now this is the formula we derive. Right. Now we have got the valuation. Now we know that P0 is equal to D0 into 1 plus G divided by K minus G. That is the answer. I think now with the comprehensive mathematical form, you have arrived at that answer. I could have just given that answer to you without giving any details. But I think you need to have a certain idea about it. You don't need to derive it, but you need to have some idea. I think this idea is enough for you. Now you know why we have done it. No, you don't need to by heart the formula of geometric series summation or whatever. It's not necessary. But you need to see how it has been arrived, how we have arrived at this. Right. Now the final part. Now I just used the formula there. In the formula I told you, for a geometric series of infinite number of terms, you get a summation as A divided by 1 minus R. A is the first term, R is the common ratio. Then A is 1 plus G over 1 plus K. Then in the denominator, you get 1 minus 1 plus G over 1 plus K. When I solve it, you get this thing 1 plus G over 1 plus K come to the denominator, numerator. Denominator, you get 1 plus K minus 1 minus G. 1 minus 1 cancelled off, and then there you retain K minus G. And there another denominator is there 1 plus K. Then when you divide, what happens is you have to get the reciprocal of that. Reciprocal. Now, when you get the reciprocal, what happens is that 1 plus K goes to the other side, the upper side. That 1 plus K remains same. And that workings I have done here. I have done it here. Then 1 plus K and 1 plus K cancelled off. Then 1 plus G divided by K minus G retains here. And D0 is also there. So this is the formula. Then P0 is equal to D0 1 plus G divided by K minus G. And this also can be written as P0 is equal to D1 divided by K minus G. Now this is known as the one-stage dividend discount model. We call it one-stage dividend discount model. So under the one-stage dividend discount model, you get the price of the present price of the stock as D1 divided by K minus D. D1 is the dividend for the first year, and K is the required rate of return, G is the growth rate of dividends. That is how it goes. Or otherwise we can say P0 is equal to D0 into 1 plus G divided by K minus G. Are you okay with that? So that is what you call the one-stage dividend discount model. One-stage dividend discount model. Yes, Sasanka. I think I have seen 2-3 persons joined in this exercise or activity. I think I really ask you to do that, because that will help you to have a good understanding. Now I have just arrived at that formula, but it's a very simple formula, and it's very easy for you to remember. Just say P0 is equal D1 divided by K minus G. But what are the conditions? Invariably, K has to be greater than G. Now I am asking a small question now. Say, as Asanka also asked, if K is less than G, what will happen? If K is less than G, what will happen? Now, what I want to tell you is, now we have arrived at the formula. Very simple formula to evaluate the stock value. What is the formula? P0 is equal to D1 divided by K minus G. D1 is the first year dividends. K is the required rate of return. G is the growth rate of dividends. Now, if you just look at it, now I am asking a question. Now I think you got the formula now, no? P0 is equal to D1 divided by K minus G. If you want to replace D1, you can replace it with D0 into 1 plus G. That also possible. That is also possible. So then you can even say P0 is equal to D0 1 plus G divided by K minus G. That is also possible. Right. Now what I am asking is, if G is greater than K, what will happen? Now there's an assumption. Actually, we assume G is less than K. With that assumption only, we have arrived at that formula. But even say, if you find G is greater than K, what will happen? Yes. What will happen? Yes, very good. Price will become a -1. Price will become -1. Can it be? Would it be possible? Would it be possible? That's what I'm asking. It's not possible in reality. It is not possible. But if I think I'm just asking you, are you in a position to explain it with the physical way? Physically, can you explain that? What do you mean by a minus price? What do you mean by a minus price? No. No, it's not the case. Negative net assets means it has a minus net worth. It is not minus price. Now just look at it, because growth rate of dividends is higher than the rate of return. So that is the issue. That can happen. That can happen for even a very good company will have that situation. So what is the meaning of that? What I am asking is, negative equity. No, it is not negative equity. So if you think that way, it is wrong, because this is another phenomenon. This is another phenomenon, not negative growth. Not negative, because it is not, no, G has not become minus, no. The price has become minus. What is the meaning of that? Because, when you say price is minus, you can't really apply, because you have to just omit that, since it is unrealistic. But what I am asking is, this is some interesting type of a thing. What I am asking is, how are we going to physically explain that, a minus price, the nature of minus price? It is not negative growth. If you have a result as G has a minus value, that's okay. That is a negative growth. That's okay. But it is not the case here. Price has become minus. What is the meaning of a minus price? In physical terms, what I'm asking is that, not worthy stock to be invested. No. 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 I mean, you have not that the thing in the first place, this value will not be taken seriously. So that is the first thing. No? But what I am asking here is, it is not the demand supply situation or whatever. What I am asking is, how are we going to explain that? That's what I am asking. Physically explanation. Can you remember, I think, say about a couple of months back, I have seen a TV advertisement of Otturoti or something. They have, I think in that particular advertisement, they say that they give Otturoti together with money. Can you imagine now? That situation is similar to this situation. Because when you want to purchase a good, you have to pay a price, no? If you want to purchase a good, when you get the price together with money, that is the same thing, no? I mean, it is the minus price. Now, when you purchase something, you have to pay money, no? Now, instead of paying money, if you receive money when you purchase a good, that is minus price. Do you agree with me? What do you say? Yes. Asanka agrees. Huh? He agrees with me. Now it's like, some person said my kothuroti is priced minus 10 rupees. What does that mean? If someone goes to get a kothuroti, in addition to the kothuroti, he will get another 10 rupees also. That type of a thing. I don't know whether you agree with me. That is the meaning of minus price. I think there's another situation in different Asian countries, in dowry, giving a dowry with the bride. That is also minus price, is it? You get the goods together with the price. That is same as minus price. Okay. No, these things are interesting things to discuss. If you don't discuss this type of thing, then it's become very boring. No, that's what I am just giving this type of things to you. You also can think of these things. Right. Now we have arrived at a very, very important formula to arrive at stock values. If you want to ask anything, just clarify anything. This is the time for that. Right. Shall we go to the lesson again? Now we have armed with the formula which gives the price of a stock, and that is D1 divided by K minus G, or D0 into 1 plus G divided by K minus G. That is the present price of a stock. Right. We will go to the lesson again. All these things we discussed. Right. Now these things are already in the lesson. Na? So this is the formula. Right. Now we will go to the example, and this is known as the one-stage model for stock valuation, or one-stage dividend discount model, we call it. Now we can go to an example. The Mercury Corporation recently paid the dividend of $4 per share. Dividends have been growing at annual rate of 8%, and this growth rate is expected to continue in the foreseeable future. If the required rate of return for Mercury stock is 14%, what is the value of its stock? Now, in order to solve or work out this type of a sum, first thing what we need to do is we need to just jot down the data available. Right now, that's how we have arrived at the solution. D0, that is the present dividends, $4 per share. So D0 is $4. Then it says the growth rate, a constant growth rate for a long period of time, it is been there, and it is 8%. So G equals 8%. And it says the required rate of return is 14%. So therefore, K is equal to 14%. Right. Now what we can do is we can make use of this data and calculate the price. Now we can apply the formula. P0 is equal to D0 into 1 plus G divided by K minus G. Now when we apply the things here, D0 is equal to 4. D0 is equal to 4, right? into 1 plus 8% is 0.08 divided by 0.14 minus 0.08. So the 0.14 minus 0.08 comes to 0.06. Then in the numerator, you get 4 into 1.08. And when you work it out, you get the answer as $72. So the stock value is $72. Then we go to another example. The Jackson Corporation has a required rate of return of 16% and its current dividend is $3 per share. If the current price of Jackson stock is 55 per share, what is the growth rate of its dividends? Now it is been the other way. You have to do a reverse calculation here. Now here you need to find out not P0, you need to find out the growth rate. When other information given. So D0 is $3. The price is also given 55. K is 16. There is a required rate of return 16. But we have to find out G. So then we need to do the substitution there. 55 is equal to 3 into 1 plus G divided by 0.16 minus G. Now you can see how it has been solved. G is equal to 10%. There are different examples given here. In another example, the common stock of the Blue Diamond Corporation is currently selling at $60 per share. Dividends per share have grown from 150 to the current level of 4 over the past 10 years. This is a little challenging question. Dividends per share have grown from 150 to the current level of 4 over the past 10 years, and this dividend growth is expected to continue in the future. What is the required rate of return for the Blue Diamond Corporation? Now the required rate is K. G is not given in the particular way, but grown from 150 to the current level of 4 over the past 10 years. So then you need to look at the growth rate. But required rate of return also to be calculated. Now look at it. Now you look at it. We should find the dividend growth rate G first. If the future dividend is DF and the present dividend is DP, then DF is equal, DF is the future dividend. It is equal to DP into 1 plus G to the power 10. So then we put 4 as the future dividend and it equal to 150 into 1 plus G to the power 10. And you can see the way it has been solved. 4 divided by 150 is equal to 1 plus G to the power 10, and 1 plus G is equal to 10th root of 4 divided by 1.5. 10th root of 4 divided by 1.5. That comes to 1.1031 minus 1. So 10.31 is the answer. Anything you need to clarify here? K is calculated after substituting the value for G. K is calculated as 17.66. Anyway, now we will see how we can work out a particular problem of this nature. And I try to put some capital asset pricing model data also into this type of a thing. Then you will learn how you can use these things in other aspects also. Right. Okay. Now, Asanka's concern has been discussed in this question. The Bahirav Mining Company has been experiencing a 6% per year decline in its cash dividend growth rate for the past 5 years. This decline is expected to continue. Bahirav has a current dividend per share of $3. If Bahirava's required rate of return is 14.5%, what is the share of a stock worth? Now, can you work it out yourself? The supplementary problems number 1. The Bahirav Mining Company has been experiencing a 6% per year decline in its cash dividend growth rate for the past 5 years. This decline is expected to continue. Bahirav has a current dividend per share of 3. If Bahirava's required rate of return is 14.5%, what is the share of a stock worth? You can directly apply the formula. Ruchira also has arrived at the correct answer. Very good. Now, when you get an answer, try to put it to the nearest 2 decimals, because this is about a price, no? So therefore, it should be to the nearest 2 decimals. I think the most correct answer would be 1376, not 75. I think, because you will get an answer like this: 3 into 0.94 divided by 0.205. 1375.6 you get. So therefore, you can say 1376. Anyway, I mean 1375 is also okay, but what I want to tell you is, when you just arrive at a price, and that price has to be taken to the nearest 2 decimals. So Deepika and Ruchira has arrived at the answer. I will explain it. I will explain it later. But I just want to do, all of you should do it. Then only you can learn these things. Otherwise, just to just have a listening or whatever, I don't think that you can understand the things in a better way. Because the necessity here is to, if you go into a decision-making level, invariably you need all this data and this information. Then only you can take better decisions. That will help your organization to be a better organization. Now, you need to develop that power. I want more answers from people who engage here. Now, anyway, I will just orally give some instructions on this. Invariably, we have to apply the formula. That formula is P0 is equal D0 into 1 plus G divided by K minus G. That is the formula. Now, when you apply that formula, I think as per the problem, As per the problem, the Bhairava Mining Company has been experiencing a 6% per year decline. Now it says a decline. So therefore, you can put down D is equal to minus 0.06. 6% is 0.06. So therefore, you need to notice or register it as D is equal to minus 0.06. In its cash dividend growth rate for the past 5 years, this decline is expected to continue. Bhairava has a current dividend per share of 3. Now what is that? D0 is 3. Required rate of return is also given, that is 14.5. So K is equal to 14.5. Now stock worth means the price is asked. So how do you calculate that? So 3 is the dividend D0. So 3 into 1 plus G. But G is minus. So therefore you have to put 1 minus 0.06 in the denominator, in the numerator. 3 into 1 minus 0.06. 1 minus 0.06 would be 0.94. 3 into 0.94 comes to the numerator. Denominator you get G minus K. Sorry, K minus G. K is 0.145 minus J. Now, G is, there's a minus value for G. So then what will happen? Now you have K as 0.145, then minus, G is also minus, minus, then it will become plus. Then you have, in the denominator, you have 0.145 plus 0.06. That comes to 0.205. Denominator you have 0.205. In the numerator you have 3 into 0.94. When you solve that, 3 into 9.94 divided by 0.205, you will arrive at 13.76. That is the answer. Any questions on that? Any questions on that? Sometimes even though you get an answer, you may not have a good understanding. That can happen. But rather than having an answer, if you have an understanding, that would be better. But that doesn't mean that you should not get an answer, but that is your practice. You need to practice it. Now, I like others also to do this. Right. With that, I will give you a small break and I will come back by 3:45. Right. We will see now. I just explained the particular supplementary problem on the board. Now you just went through that. The Bhairava Mining Company has been experiencing a 6% per year decline in its cash dividend growth rate for the past 5 years. This decline is expected to continue. Bhairava has a current dividend per share of 3. If Bhairava's required rate of return is 14.5%, what is the share of a stock worth? Okay, I will just explain it on the board. Now, the available information we have jotted down this way. E0 is equal to 3. G is equal to minus 0.06. Now, rather than put in 6%, I have just put 0.06 because this is a decline. So therefore, we have put it as minus. Now, I think one person has a concern while dividend growth, when we just considered about dividend growth, one person has a concern that when there's a decline, what will happen? So there's a way we can apply that. G is minus 0.06 and K we have to find out. Sorry, K is given. It is 14.5. Now, when you say 14.5, it's a percentage. Whereas we can apply it on calculations, we have to put it as 0.145. So we call it a decimal presentation of percentages, 0.145. And we need to calculate P0. Now, here when you if you work out the problem in the examination, you have to write down something. So you just say applying the one stage dividend model. D0 is equal to D0 1 plus G divided by K minus T. Now we can apply these things here. D0 is 3, 1 plus G. 1, G is minus 0.06, so 1 minus 0.06. Then divided by K minus G. What is K? 0.145. Minus. G is a minus value, so therefore we can put minus 0.06. Now this is given as 3 into 1 minus 0.06 is 0.94. Here you get 0.145 minus 0.06, that is plus 0.06, and it equals to 3 into 0.94 divided by 0.205. Now when you add 0.145 to 0.06, you get this value. And when you calculate, you get a value of 13.756, and we can say 13.76 to the nearest 2 decimals. Okay. I think that you have got a good understanding on application of the formula. Okay. We'll see now. The second question also we can look at. The Quaker Corporation's risk-adjusted cost of capital is 10%. Quaker's current cash dividends per share 250 and have been growing at a 3% per year. However, a technological breakthrough is expected to increase Quaker's growth rate to 6% for the foreseeable future. Now, it seems that since they have some technological breakthroughs, they expect the dividend growth to be increased to 6%. Whereas common stock has been selling at a 35 to 38 range. Now, just look at the question, the way it comes. Part A, what do you expect the stock price will be after Quera's new technological development is announced publicly? Yes. Now, this is an answer which you can give even just without doing any calculations. You can say something by looking at this question. Now, try to get some understanding for this question and see how you can answer this. First of all, you gather what the question said, then you need to see how you can apply the things available in the question, the information available in the question. Queer Corporation's risk-adjusted cost of capital is 10%. Whereas current cash dividends per share 250. That is D0 is 250 and have been growing at a 3% per year. So that is G is equal to 3. However, a technological breakthrough is expected to increase Quera's growth rate to 6% for the foreseeable future. Common stock has been selling at a 35 to 38 range. Now, when the growth rate being doubled, now 3 to 6% means it will be doubled. What do you expect the stock price will be after Quera's new technological development is announced public? Yes. So answer that question. Now you need to say that whether you expect the stock to be priced at a higher level or lower level or whatever. So that type of a answer I expect. Yes, I think it's really simple, not that difficult, because yes, Ruchira has said, yeah, Pradipika, yes, so all of you are correct. Now, how do you give that answer? How did you give that answer? Just explain something, just give a reason for that. Price will increase, the answer is correct. It will increase. Why it will increase? If you go into the formula, you will find that P0 is equal to D0 1 plus G divided by K minus G. Now, when you say G is increased, what will happen? The numerator will go up in value. And what will happen to the denominator? Denominator go down in value. Now, when the denominator goes down in value and numerator goes up in value, what will happen? The whole thing will go up. That is how we deduct it. Even without a calculation, we can say that. The price increase can be expected by looking at the formula. Now, I will show you how it happens. I will show you how it happens. Now look at this formula. Now, when G is going up, what will happen to this? It will go up. It will go up in value. Now, that portion is called the numerator. And while the numerator is going up, what will happen to the denominator? When G is becoming higher, K minus G will become lower, smaller. Now, when you have a smaller value in the denominator, the whole thing will go up in value. So, if you have a growth or the value increase something here, it will be doubled or tripled by this. So, therefore, you will have a marvelous value increase. So, that of course, we don't need to do a calculation even. We can just look at it and tell. So, in your decision making process, these type of aspects you have to understand. Because then it will be very much important for you to take decisions. So you will take very effective decisions if you understand these things correctly. Right, now we will go to the second part of it. What do you expect the stock price will be after Quera's new technological development is announced publicly? B. Does the stock price change you suggested in part A seem rational in view of the fact that the Quera Corporation will still have the same management, the same physical assets, and the same product as it did before the announcement of new technology? Right. So this is also a very analytical type of a question. Again, it says, does the stock price change you suggested in part A seem rational in view of the fact that the Quera Corporation will still have the same management, same physical assets, and the same products? Now, what it suggests is whether you agree that this should happen in this manner with the same physical assets, with the same type of management and same products. Right, what do you say? So you need to have some answer for this also. And you need to do some calculation also, because since in the question there have been several numerical information given, and you are in a position to arrive at certain answers by calculating something. That is also to be done. Yes, but first of all, you give a verbal answer or some sentence with some sentence without using the figures. You can give some answer. Now, what the question asks is whether it is rational. What do you say? Yes, I just expect and I look for your answers, because you need to, as one or two persons do, others also should join in the discussion. And that will help you to have a good understanding and good decision making power. Pradeepika, what do you say? Even with same management, same products, same assets, would they be possible to have a high price? Yes, you can really explain that. Yes. Now I think Pradipika has given an answer that it is yes, and whether it is rational. Yes. So then you have to give reasons for that. Now, if you don't give reasons, your answer will not be, you say, not very serious. Now, say yes or no answers are not that serious. So what you have to do is you have to just say what you want to say and say why you have said it. And at the same time, what you need to do is you need to do a calculation and show. Now, I just want you to do at the time of 3% growth rate, what would be the price? And at the time of 6% growth rate, what would be the price? So that you need to do. You do that and then arrive at the price when the growth rate is 3% and arrive at the price when the growth rate is 6%. You can do a comparison there. First of all, you calculate the price when the growth rate is 3%. Very good. I think Pradipika has done the calculation, and she said that current price is 36.78 and expected price is 66.25. I think the price has been increased. It has been increased to 66.25, and it is just an increase of 3 to 6% of dividend growth. It is nothing to do with other things. But there's a small news going on, that is the innovative type of technological innovation. Now, when you say technological innovation, that really add value to the organization. That is how the price has increased. It shows the price increase being shown in the calculations also. So I will see whether the answer is correct by looking at the figures. We'll see. K is 10%, 250 is the D0 and D0 250 into 3%. 250 into 1.03 divided by K minus D, 0.1 minus 250 into 1.03 divided by 0.1 minus 0.03. Yes, 36.78. That is the, now it says that whereas common stock has been selling at a 35 to 38 range. So I think your calculation really comes in the same range. This is the present situation. But when you calculate it with the growth of a 6%, you will come to 250 into 1.06 divided by 0.1 minus 0.06. 66.25, it seems. Yeah. And as Pradipika correctly mentioned, the price will become 66.25 when the growth is 6%, and when there was the normal growth, the price was only 36.78. And you can clearly see the increase in price even without any change in the physical assets, without any change in the products or whatever. But there's an indication that they had a technological innovation. Now you see, when with the technological innovation, they have been able to increase their dividends, the growth. While doing that, their prices also been increased. Anything else you need to clarify on this? Right. Now with that, I want to show you some real-time results on dividends in Sri Lankan context. In Sri Lankan context, we will see what type of things which has to be checked in. Yes, now I will go to the Colombo Stock Exchange monthly application. Yes. Now look at it. Now I want to just show you something regarding the dividend declarations. Just look at it. and make sure that you go through all these documents, right? I have just put some documents into the into your class, and then you also will be able to go through these things. Right. Now it says dividend announcements as at 39/2021. And the particular dividends being declared on as at 30th September 2021. Dividend announcements being given here. Right, now you can just see Lanka Ventures PLC. The dividends per share is declared here 150, and it is the final dividend. It will be registered on, and the particular payment will be made on 15th of October 2021. Now, this is the particular information given with regard to the dividend declaration and the payment of dividends. And LVL Energy Fund Private Limited, there you have a cents 35 dividend, that's a small dividend, and another 2 rupee dividend. LPTA Plantations, Aitken Spence, 8 rupee dividend, and Harishchandra Mills Limited, 30 rupee dividend. It's a final dividend. Some you have seen first and final that way. I mean, there can be several ways of doing it. Mahavali Coconut Plantations PLC 150. So likewise, now you can see some organizations has given high dividends. Now you can see Harishchandra Mills Private Limited. So they paid the 30 rupee dividend. Maybe the share value may be higher. Abans Electricals 3 rupees per share. You can just look at it and see what type of dividends Dilma Ceylon, 18 rupee dividends. Lanka Milk Foods CWE, that is 5 rupees dividends. Hunters and Company, 10 rupee dividends. Singa Sri Lanka, 30 cents. ACARB, 80 cents. Alumex, 10 cents. Elise Fabric Limited, 40 cents. Dip Products, 95 cents. Likewise, now dividends being declared. Serenity Brand PLC, that declared 25 rupee dividend. Annual Plantations, Elise Fiber. Now you can see these are the declarations. I mean, this may not be restricted to only month of September, but in other months also there can be dividend declarations. And as you say, now we have already done some calculations on the basis of dividends, basically. There we calculated the stock value or stock price by going through the dividends. But we have had several assumptions. Sometimes it looks funny. Yeah, several assumptions where it is very much far from reality. Very much far from reality. Now just look at it and see. If you look at these dividend declaration forms and all, you will find that it's very, very rarely a company declares the dividend with a uniform growth for several years. Whereas we apply those things and we just assume the dividend growth is constant. That is what we assume. But you will find out how far it is from reality. So that is one part of it. And not only that, the other assumption is always we try to see the growth rate of dividends should be lower than the required rate of return. That is also very unrealistic type of a thing, but in that particular situation, many companies follow that. But there are some starting companies or startups or whatever, they pay very high dividends in the beginning, but they want to attract their shareholders to the venture. In order to attract the shareholders, they do extraordinary type of dividend declarations at the beginning. So then the stockholders, they stick to the company. These are the types of conditions where you have to expect in the market. Now, most of the time, there can be dividends, we call them interim dividends. Final dividend means that really closes all the dividends, and that is the final one they receive on dividends for the year. But in our calculations, we assume that dividends being declared and paid only once in a year, and for the year, total year concerned. And that amount is a reasonable amount. But you need to see how these dividends been grown and whether these growth rates are similar type or similar. That's all you have to see. So that's what I ask you. You can just go to the Colombo Stock Exchange, the documentations or information files or whatever. There are possibilities because you can just access the website of Colombo Stock Exchange. And there are several links where you can get the appropriate information and see how the dividends being grown for certain companies. Now, if you can find out high standing companies or 5 or 6 high standing companies and see how their dividends being grown for the last couple of years and see whether the growth rate has a constant type of behavior. So that is what you need to look at when you go into the Colombo Stock Exchange website and find out the dividend declarations, the company profiles and all that, and you will see any type of a pattern available in that with regard to the dividend declarations and all, and even the prices of stocks. So that you can do by surveying the Colombo Stock Exchange daily. If you don't find information there, I mean, there are some short-term information in the daily reports also. That is also a possibility you can do. Anyway, now we will go to the right question again. Right, we will see question number 6. Well, I just keep some of the questions to be done by yourselves, because if you find it difficult, then I will explain it. But today the question number 6 we will see. ABC Corporation's dividends per share have grown at a rate of 6% per year for the past few years. If this rate continues in the future, determine the value of ABC stock. Growth rate is given, that is D equals 6%. ABC's current dividend per share is 350. So D0 is 350, risk-free rate is 9, that is K equals 9. But only problem here is risk-free rate, even though the risk-free rate is given, the required rate of return is not given. But how are we going to arrive at the required rate of return? By extracting the information available in the question. Yes. Because in order to calculate the ABC stock, now if you apply the one-stage dividend model, what will happen? We need to have D0, we need to have G, we need to have the required rate of return, K, into the calculation. Growth rate is given. Yes. So what are you going to do? I told in the at the beginning. Now this dividend discount model has a relationship with the capital asset pricing model also, because that relation comes with the required rate of return part. So that required rate of return is given with another relationship together with beta. So that is the capital asset pricing model. So you can just make use of that capital asset pricing model and arrive at the answer. Yes. Now, what you need to find out? You need to find out the required rate of return. Or in other words, the equilibrium rate of return. How are we going to arrive at that? Now, in this question, the risk-free rate is also given. Market return is given. Beta is given. So what else you need? So you can calculate the required rate of return of the stock ABC, because it's a beta is also given. So just apply the capital asset pricing model and come arrive at the required rate of return of stock. Yes. Now, first of all, you find out the required rate of return. So that is the first thing which you need to do. Calculate the required rate of return of ABC. You need to use the capital asset pricing model. Yes. One, two, three. Yes, required rate of return. Can you calculate? Yes, Samit. Ruchira, correct. Samit, okay. All others should try this. Try that and see. Now, with the required rate of return of 18.1, you are in a position to calculate the stock price. Stock price also be calculated. Now, you have to familiarize yourself with these fundamentals of capital asset pricing model, capital market line, efficient frontiers, portfolio theory, and all that. And irrespective of the assets, you should be in a position to arrive at the portfolio returns, portfolio risk, and all that. Even if you have portfolios with treasury type of assets, treasury type of instruments, there you have to see what type of risk is available, whether it is not available or whether it is available or that type of things. So with that, you will be in a position to calculate the portfolio risk and returns, even together with government type of assets or instruments. But there you can see the risk element is not available in the treasury instruments. So it will be distributed among the other risky assets. Right now, I think some people have arrived at the required rate of return, that is 18.1. So with that, you will be in a position to calculate the stock price. The current dividend is given 350 into the 6% is the growth rate, 1.06 divided by K minus G. K is 18.1, that is 0.181 minus G. G is 0.06. Right. Just look at it and see what is the answer. Yes. Anyone who tried that? Samit Sivant and Ruchir Herath has arrived at an answer. We'll see. What is it? Ruchira has got the answer. Yes, it seems it is correct. Yes, others also should try. Yeah? Others also should try. Okay, I don't know. People who have not done it, you have any issues or you have any uneasiness or anything, any confusion on this? Is it necessary to explain it on the board? Right now, if you go to the question again, the ABC Corporation's dividends per share have grown at a rate of 6% per year for the past few years. If this rate continues in the future, determine the value of ABC stock. Assume ABC's current dividend per share is 350. Risk-free rate is 9%. Market return is 16% and beta is 1.3. It's an aggressive stock since it is 1.3 and it is higher than 1. Therefore, it's an aggressive stock. Now, since it is an aggressive stock, 6% growth is there. Now, ABC stock value we need to calculate, but we have to go through required rate of return because since we do not have any other information or any the required rate of return is not available, so we need to first calculate the required rate of return. That some of the 2-3 persons have calculated, but anyway, I will just explain it on the board. Now, I think as a rule or as a habit, you need to develop that habit where you need to jot down the information available in your sheet. Now, ABC Corporation dividends per share have grown at a rate of 6%, so we can say D is equal to 6%. Then again, it says if this rate continues in the future, determine the value of ABC stock. Assume ABC's current dividend per share is 350. So that is D0. D0 is 350. Risk-free rate, that is RF, is 9%. Market return is 16%. That is RM. Or expected return on market. That is also. And beta is 1.3. Beta. Now these are the information available. Now it seems that we need to assume first of all we need to get the required rate of return to calculate the company share value. So then we can say right. Assume the required rate of return as R. Okay, we can say K. Then using the capital asset pricing model, K is equal to RF plus RM minus RF into P. So RF is 9%, RM is 16%, minus 9%, beta is 1.3. Now here you get 9% plus 16 minus 9 is 7% into 1.3. 7.3 into 1.3 becomes 9.1%. And here 9%. Altogether it is 18.1%. This is the required rate of return. 18.1. Any questions on that? Now, when you work out the sum like this, you have to write down all these sentences. And it gives a good meaning of this. And an examiner can see what you have applied and what type of fundamental mechanism you have applied to solve your question, solve your problem. That is very important because you might get marks for these steps. Now that is how that 18.1 comes. Later on, we can apply. Now K is also available, and we have other data, and we can arrive at the price. Right. Then we can go into the next formula. The price of the stock T0 is equal to D0 into 1 plus G divided by K minus G. Now here we can apply. What is available we can apply here. D0 is 350. 1 plus G is 6%. 6%. 6% is 0.06. So 350 into 1.06 divided by K minus G. K is 18.1. G is 0.06. And we can calculate it. 350 into 1.06 divided by 18.1 minus 0.06. What is the value there? 18.04. When you do the calculation, you will arrive at the answer. Sorry, I think there's a mistake here. 18, we can't put 18.1 here because it is 0.181. 0.181, not 18.1. Make sure you always put it in decimal form. 0.181. 0.181 minus 0.06 becomes 0.181 minus 0.06. 0.121. That comes to 350 into 1.06 divided by 1.121. 30.66. This is the value. This is the stock value. 30.66. 30.66. The stock value is that. Any questions on that? Any question on that? Right, now we will see the other rest of the lesson. Now I think we have to go for some other examples. The stocks with substantial annual growth of dividends. Now, as I told you earlier, some startups basically, in order to attract their shareholders to the company, what they do is they tend to pay very high values of dividends. And it results in having a substantial growth in the first couple of years, initial periods. However, this trend gradually comes to a lower level after several years of initial operations. Now, that happens generally because in the first couple of years, they try to become very active and they want to show that the people that they are a very high growth company and they will become market leaders in a couple of years. And they want to just make that image in the minds of the investors, and they want to just see that their company is attracted by people, investors. They put investments into the company and the company capitalization will go up. So that is the idea behind that. So what happens is, now when this happens, as one of our assumptions will go for a 6, because G would be higher than the required rate of return. Then what will happen? If we apply our normal one-stage dividend model to arrive at the price of the stock, you will be disappointed because you will get a minus price or minus value, which is not rational, and we are not in a position to calculate the price of a stock when that situation is present in a company. Therefore, we need to invent, or we need to follow another way of arriving at the stock value of that company. Now that particular methodology is known as the two-stage cash dividend model. Two-stage cash dividend model, because if you apply the one-stage model for that, you will not be able to arrive at the realistic value. So therefore, we abandon that methodology. When you calculate stock prices for a company where the required rate of return is lower than the dividend growth rate. Now we can go to the two-stage cash dividend model for stock valuation. Since the one-stage model cannot be used in the above scenario, a two-stage dividend valuation model where dividends can grow at an above normal rate for several years before dropping into a more normal rate is more realistic in cases of this nature. The two-stage model is given for the calculation of stock price, and the formula is as follows. Now this is the formula, but I think it's very cumbersome. If you look at the formula, I think you will feel very awkward and it's difficult for you to even by heart. But I don't ask you to by heart it. But we can just go by the first principles, and it is very much easy for us to go by that method. Now, DN stands for dividends per share in time period N. G1 denotes the initial dividend growth rate, and D2 represents the longer run dividend growth rate, and N is the number of years that the G1 growth lasts. Right, anyway, now I think this we can put in a more simpler form. Now, as it is, if you feel that for a couple of years it pays a very high dividends and the growth rate is so much higher, and at the same time that growth rate is higher than the required rate of return. So what we need to do is we need to get the cash flows for those years calculated, and it has to be present value. But what we do then is we would see how long would it take to become the dividend growth to a normal level. How the dividend growth rate would become more normal. I mean, it is not a very high dividend growth, but it will come to a lower dividend growth rate at a certain level. So till that time, the cash flows being calculated for each year and get the present value, and the total of which will be calculated. So that is the first stage, the first stage of it. The second stage, now at the end of that particular period, there will be another period starting with a more normal growth rate. Then we apply our one-stage model formula for that, and assuming the dividend and the growth rate using the new growth rate, you will be in a position to calculate the price at which the stock can be sold at that point. And assuming that price has been realized, and you have to add that and get the present value, then you will get your stock price. That is how you do it. And it is a simpler way than this formula. If you go by this formula, I think it would be more difficult for you, and I think it looks like very cumbersome. So therefore, I don't recommend you to by heart this formula. But you need to understand that there are two growth rates. The initial growth rate, and this is a very high growth rate, and it is higher than the required rate of return. And the second level growth rate, which is more normal and which is lower. And at that time, it is lower than the required rate of return. So that is how we do it. Anyway, now we will see how we can do it by looking at the example here. The Saturn Computer Corporation has been experiencing an above normal dividend growth rate of 20% per annum for the last 5 years. This above normal growth rate is expected to continue for another 5 years before it levels off at a more normal rate of 6%. Saturn's last dividend was 50 cents per share. Determine the current value of Saturn stock if its required rate of return is 50. Right. Anyway, now we, as usual, what we do is we just jot down our information. G1, that is the growth rate at the initial period, it is 20%. Growth rate at the second period, it is 6%. D0 is 0.05, that is I think there's something wrong here. It should be 0.5, not 0.05. $50 per share. $50 means it is 0.5. 0.5, right? So it should be 0.5. K equals 15, that is correct. And N equals 5. Because for 5 years it happens. Now just look at it. Now, these are the first 5 years. And you do the cash flows and get their present values. This is D0, 0.50 into 1.2 because the dividend growth rate is 20%. This is the second term, that is 0.5 into 1.2 to the power 2 divided by 1.15 to the power 2. Likewise, it goes up to 5. Right? And what we have done here is we have gone through all the dividend cash flows in the coming 5 years. We have calculated the present values of all those cash flows. And what happens at last? Now, after 5 years, the dividend growth has become lower. Now, it has become from 20% to it has come down to 6%. So then we are in a position to apply one-stage dividend model for that. For the 5th year, so that is, now if you want to put it in price terms, we can say it is P5. For the 5th year, it is P5. Sorry. 5th year, it should be, yeah. 5th year. Now then we have to, what we have to do is, 5th year, that is P5 is equal to E5 into 1 plus G. E5 into 1 plus G divided by K minus G. So that is the application of the one-stage dividend model for that. Now, why do we apply that? In order to have the price of it. And that price has to be present value. And it has to be divided by 1.15 to the power 5. That's what we do. So that is also been added to the all these 5 cash flows. And when you solve it, you will get the value. Any questions on this? Any questions on this? Now, what I want to tell you is now there's a need to calculate the value of a stock where the dividend growth rate is higher than the square rate of return. If you try to do it through applying the one-stage dividend model, you will not get a realistic value and you will get a minus price. So it is impossible for you to arrive at a price by applying the one-stage model. So therefore, what we need to do is we need to go for the two-stage model to calculate the price of such a stock. And what we do is we get the initial growth rate of dividends and calculate the cash flows of that dividends and get the present values and total up. And at the end of that period, there will be another period starting with another growth rate. And that growth rate is lower than the required rate of return. So at that point, we need to calculate the price of the stock. And assuming that stock being sold at that price, and that price has to be present value and added up to the earlier cash flows. Then you will get the answer. That is how this price is determined. Yes, we'll see the example. Now, just look at this example. Now, I will put it in two stages where you understand these things. The first stage is to calculate the cash flows during the high dividend growth period. Now, in this particular case, the high dividend growth period is 5 years. For that 5 years, these cash flows are given. Here, you look at it. This 0.50 into 120 divided by 1.15, that is the first year's cash flow, dividend cash flow. This is the second year's dividend cash flow, that is 0.50 into 120 to the power 2 divided by 1.15 to the power 2. In the third year, it is 0.50 into 1.20 to the power 3 divided by 1.15 to the power 3. In the fourth year, it is 0.50 into 1.2 into 4 divided by 1.15. In the to the power 4. In the fifth year, 0.50 into 1.2 to the power 5 divided by 1.15 to the power 5. Now, the chapter is, the first chapter is over there. Now you get it. These are the cash flows for the first 5 years, dividend cash flows, and present values also been taken. Now, then we assume at this point, this particular stock is going to be sold. It would be sold. Now, if it is going to be sold, then what will happen? We will have to see what would be the price at that time. Now, price at that time means, so P5 is equals D6 divided by K minus G. What do you mean by D6? D5 into 1 plus G2, because that now the next dividend growth period has started. At the next dividend growth period, the dividend growth rate has become very small, not that high. It has become, now in this particular case, it has become 6%, that is 0.06. So that is why. Now we have taken the fifth year dividend, that is 0.50 into 1.2 into 5. No, sorry, sixth year dividend, that is D6. 0.50 into 1.2 into to the power 5. So that is the sixth year dividend. Sorry, not sixth year dividend, it is the P5, and sixth year dividend is that D6 divided by K minus G. K is 0.15 minus G is 0.06. And it has to be present valued. And it is to be multiplied with 1.06. And it is to be present valued by dividing 1.15 to the power 5. And you get the value 7.29 there. And these values are being, first year it is 0.522. Second year it is 0.544. Third year it is 0.568. Fourth year it is 0.593. Fifth year it is 0.619. And this the last situation where the particular stock is sold. If it is sold, now this can be realized. And the present value is 7.29. Altogether, the value comes as 1014. The value of the stock is 1014. Anything you need to clarify there? Yes. Right. Now we will go to the supplementary problem 3. The Nilgala mine company has been experiencing rapid growth during the last few years. Analyst expects 30% growth rate in dividends to continue for the next 4 years. After the above normal growth period ends, dividends should grow at a more normal rate of 6% thereafter. Nilgala has a current dividend of 260 per share. If Nilgala has a required rate of return of 17%, what is the value of the stock? Now, first of all, we need to see whether this this calculation would be done using the one-stage model. If it can be done using the one-stage model, it is very good. But we can just check whether it can be done. How we can do that? Now you can look at the growth rate is 30%, whereas the required rate of return is 70. Now what is happening now here? The dividend growth rate is higher than the required rate of return. So therefore, we are not in a position to apply the one-stage dividend model for this particular problem. So therefore, invariably, we have to go for the two-stage model. We have to go for the two-stage model. Right. Now we will see how we are going to do it. Right. Now, the growth rate is 30% at the beginning. And not only that, it says the second level growth rate is only 6%. The current dividend is 260. Therefore, and it says in the question, it says how long would it go? The high growth, it will go for 4 years. 4 years. And we will have to calculate the things, calculate the cash flows for 4 years at the beginning. So first, what would be the first cash flow? 260 into 130, 1.30 divided by 1.17. That is the first year's dividend cash flow. And it is taken to present value. And the second year, it would be 260 into 130 to the power 2 divided by 1.17 to the power 2. In the third year, it would be 260 into 1.3 to the power 3 divided by 1.17 to the power 3. In the fourth year, it would be 260 into 1.30 to the power 4 divided by 1.17 to the power 4. But at the end of the fourth year, what will happen? At the end of the fourth year, the price is called P4. P4 is equal to D5 divided by K minus G. Now, what are we going to do there? So, what is D5? D5 is D4 into 1 plus G. Sorry, D6 is D5 into 1 plus G. So, what is D5 into 1 plus G? What is D5? D5 we have already calculated, that is 260 into 1.30 to the power 4. That is 4, D4. Right, we will do it on the board. Otherwise, I think you might get confused. So we can do that way. Right, now I will take down the information into the board and just work out the things on the board. We can say D1 is 30%, A is 17%, D0 is 260, and G2 is 6%. High growth period, years. Now, you can say the first step, cash flows, PV of cash flows, yes. Now, then we have say the first step, present value of cash flows for the first 4 years equals first dividend, that is D0 is 260 into 130 divided by 1.17. This is the first year's dividend cash flow, the present value. Second year's dividend cash flow present value is 260 into 130 to the power 2 divided by 1.17 to the power 2. Then the next one, 260 into 130 to the power 4, sorry, to the power 3 divided by 1.17 to the power 3. Fourth one, 260 into 1.30 to the power 4 divided by 1.17 to the power 4. Now these are the cash flows for the first 4 years. And we can just calculate it, or we can keep it as it is. Then the second step. The second step is calculating the present value of sales proceeds of the stock at the end of the 4th year. So how can we calculate that? So there we apply the one stage dividend model. What shall we do? Now there you have the P4 is equals D5 divided by K minus D. D2 here. Right? That is P4. So we can just get it. D5 is now D4 is here. D4 is 260 into 1 power 4 into 1.06 divided by 0.17 minus 0.06. So this is the price, but the present value is equal to, now this one has to be divided by 1.17 to the power 4. Now what we need to do is we need to calculate this, and that has to be added here. That is how this can be done. So I think you need to do the calculations. I have just shown you the methodology. Now, while anyway, if you have any issues, let me know. So I will explain now. I will further further clarify what has to be done. Now, this is a very important type of a methodology, the application, the two-stage model, because most of the cases this has to be applied, because you know, basically, especially for the startups, this happens. So you need to just clarify these things. Actually, I am very much happy today. At the beginning, a student is very much interested in these things, and he has asked several queries and several questions. So that's very good. That's very good, and indeed it will be helpful. I mean, all others will really get the benefit of that. Therefore, you all have to do that. I think you all will be able to just do the calculations and arrive at the answer. Anyone who tried to get the answer? So I think I just I'm waiting for the answer for you, because I have just done it on the board, and if you can solve it and arrive at an answer, so you can put the answer there. 5181, Samit, Shivant, maybe we will see. We will see. I think Samit has done a good job. He has arrived at the answer. Samit, the answer is correct. 5181. Yes. I don't know whether others have just tried to get the answer. And you try and see, and if you have any issues, then you can just discuss again. If you have any issues, so others also should do that. Yes, Pradeepika and all others. Have you doing that? Have you done that? Now you can ask any question or any clarification. You need to get any clearance or whatever, anything.
Excuse me, sir.
Yeah.
Sir, what is the meaning of risk-adjusted cost of capital in question number?
Risk-adjusted cost of capital. Yes. No, it's like this. Now, when you say the cost of capital, so what you need to do is, now, are you referring to the required rate of return? So that is, I think, in most cases, more or less, these two things are taken as similar: required rate of return and risk-adjusted cost of capital. Because now, when you say cost of capital is now. Have you heard about a thing called WACC? That is weighted average cost of capital. Now, that weighted average cost of capital, when you adjust it for risk, then we call it the risk-adjusted cost of capital. Right? Now, the meaning of adjusting for risk is, so you have to see how the risk can be compensated to the capital. So in other words, so say, for example, say now you are assuming a certain type of a risk. So that risk has to be absorbed by the capital. So what you need to do is you just the required rate of return is the risk-adjusted return on capital. So there, what you do is you calculate the return adjusted by risk. Or in other words, you assume the risk as a cost and deduct it from the total return. And risk-adjusted capital is when you deduct that cost of risk from that capital. So that is the terminology. But in this particular case, when you say the required rate of return, that is also equal to the risk-adjusted cost of capital. That is the terminology. I think you got my point.
Thank you, sir.
I will just further discuss those things at another lesson, where we talk in terms of the what you say, we will have a lesson on interest rates. Lesson on interest rates. So there we will discuss on that at a more comprehensive form. So I think you will realize it at that time. Anyway, for the time being, what I can say is we do an adjustment for cost of capital with regard to the risk, and that is what you call the risk-adjusted cost of capital. So, and that is equal to the required rate of return. And we will have a better explanation, comprehensive explanation on these things under interest rate. There's a lesson, special lesson on interest rates. Anyway, anything else? Anything else? And you try to work out the sums given in the supplementary problems. And if you feel anything difficult, so you can discuss these things. And even something we discussed, and I just explained these things on the board, and you try to do it yourself, and you will get a better understanding. And if you do that, when you do that, you feel anything difficult or whatever, then you can again come to the class and discuss it. So that is how you need to learn these things, study these things. Anything else to be clarified? Right. I think with that, we have to wind up the class today. And I expect you to study the things which we have already done. And if you feel anything to be done, you can just come up with your suggestions or comments or whatever. So I don't feel embarrassed on that. But only thing is, if you don't talk, if you don't ask any questions, if you don't argue and all, then I will be very much, disheartened. I feel very bored in that case. So therefore, you come up with your own arguments, own questions, own queries and all that. That I really enjoy. Okay, with that, we will wind up the class, and I think I just thank all of you for your active participation and engagement. Thank you very much.
Thank you, sir.